Now, in understanding GP, let's look at this series. This is my T1, this is my T2, this is my T3, this is my T4, and so on. In AP, T2 minus T1, T3 minus T2, T4 minus T3 were coming as same, what we call as common difference of AP. Here, if I divide T2 by T1, which is 4 by 2, if I divide T3 by T2, which is 8 by 4, if I divide T4 by T3, which is 16 by 8, all these ratios are giving me the same value, which is 2. So this is the common ratio of this GP series and a series which follows this pattern where T2 by T1, T3 by T2, T4 by T3 and so on comes to the same common ratio. This series is called GP. Now let's look at this. Suppose if I do T2 by T1, I am getting 1 by 4 divided by 1 by 2. This will be 1 by 2. If I do T1, T2, T3, T4, T5, T5, and if I do T6 by T5, again 1 by 64 upon 1 by 32, I am again getting 1 by 2. So the common ratio of this GP series is 1 by 2. Please note, we will always do T2 by T1, matlab the next term by the previous term ka ratio. Now, in this, the first term is denoted as A and the common ratio, which is T2 by T1 or T3 by T2 or T4 by T3 and the succession continues, is called common ratio of GP. Now let's understand the general term pattern here. Is my T1 2 here? Can I write this as 2 into 2 raised to 0? Now T2, can I write this 4 as 2 into 2 raised to 1? Now T3, which is 8, can I write this as 2 into 2 raised to 2? Now T4, can I write this 16 as 2 into 2 raised to 3? Now if I look carefully, this 2 is nothing but my first term, and this 2 raised to something is nothing but my common ratio, which is R. So if I write something like T9, I will be like 2 into 2 to the power 8. Now if I look at this pattern carefully, I will get Tn as 2 के जगह पे A, this 2 के जगह पे R, and 9 के लिए 8 है, 4 के लिए 3 है, 3 के लिए 2 है. So will this be R raised to n minus 1? This is my general term. Now, application of Tn. Finding any term of the series using Tn concept. Suppose they have given me this series and they're like, find 9th term of the given GP series. If I observe my series carefully, is my A equal to 1 by 3? And if I try to find the common ratio, I can just do T2 by T1, which is 1 by 9 divided by 1 by 3. If I solve this, I will get 1 by 3 as my common ratio. So, ninth term will T9 be A R raised to 8. Now let's put the value of A, which is 1 by 3, and value of R is 1 by 3 raised to 8. If I solve this, I am getting 1 by 3 into 1 by 3 raised to 8. If I apply the law of indices here, I will get 1 by 3 raised to 9 as my T9. We can also use Tn concept for finding the unknown GP series. Suppose they have given me find GP series if T5 equal to 48 and T8 equal to 384. So if I write this equation that T5 is nothing but A R raised to 4, which is equal to 48, equation number 1. Now T8 is it nothing but A R raised to 7 equal to 384. Now I need to find A and R here. If I look at both these equations, if I divide equation 1 with equation 2, this A and A will get cancelled, and this R, I can just apply the law of indices and I will get an equation in R raised to some power equal to value. So if I do 1 divide by 2 A R raised to 4 upon A R raised to 7 equal to 48 by 384. A and A gets cancelled. This is 1 by R cube equal to 48, 12 3s are 36, 4s are 12 3s are 36, 24, 12 2s are 4, 1s are 4, 4 8s are. I am getting 1 by R cube as 1 by 8. If I solve this, I will get R as 2. Now if I put the value of R in equation 1, I am getting A 2 power 4 equal to 48. This is A into 16 equal to 48. A is coming as 3. I have found my R, I have found my A. I can clearly find T1, which is equal to A R raised to 0, which will be 3. Now T2 will be A R power 1, which will be 3 into 2 power 1, which is 6. Now T3 will be A R power 2, which is 3 into 2 raised to 2, which will be 3 into 4, which is 12. T4 will be A R power 3, which is 3 into 2 power 3, 24. These many terms of GP series is good enough answer for this question. Now suppose they give me this. This is my series and I need to find the total number of terms. I can clearly see that my first term is 2. If I find common ratio, which is T2 by T1 or T3 by T2, I'll get 6 by 2, which is 3, or 18 by 6 is again 3. I am getting common ratio as 3. Now, can you see this last term is given? I will say let the total number of terms be n, therefore Tn will be my 4, 3, 4. Now value of Tn is A r raised to n minus 1 is equal to 4374. I will put my value of A, I will put my value of R. It will be an equation in n. Whatever is my n ka value will be my total number of terms. So let's solve this. A is 2, R is 3 raised to n minus 1 equal to 4374. If I send 2 there, 3 raised to n minus 1 is 4374 upon 2. Now, if I solve this, 3 raised to n minus 1, this will be 2, 1, 8, 7. Now this is 3 raised to n minus 1. If I prime factorize this, this is coming as 3 raised to 7. Bases are same. Equate powers. So n minus 1 is equal to 7. I am getting n as 8. That is my total terms is equal to 8. Now in sum of GP series, let's understand absolute value of R. This is represented by this symbol. Now suppose my GP ka common ratio is minus 3 by 2, then absolute value of R will be this value in positive. For example, if my common ratio is minus 3, my absolute value of R will be this value in positive. Suppose I get common ratio as 2, then the absolute value will also be plus 2. Now if I get common ratio value as minus 3 by 2, my absolute value of R will be plus of 3 by 2. Now depending on absolute value of R, my sum of GP series is decided. For example, absolute value of a GP series is 1. This series, suppose my first term is 3, this series will look like this. And so on. Because my common ratio has to come to 1. So 3 by 3 is 1, 3 by 3 is 1, and so on. So if I see, if these are my n terms and 3 is my first term, my sum will be n times 3. Now if my absolute value of R is greater than 1, then I will apply this formula, which is Sn equal to A into R raised to n minus 1 upon R minus 1. Similarly, for absolute value of R when it is less than 1, I will apply this formula. Both of these formulas are same. It is just that we are making the denominator positive. Now this is a variation in sum of GP series formula. Suppose I know my first term, I know my common ratio, and I know my last term. Then I can directly use this formula. If absolute value of R is greater than 1, I can say Sn will be L times R. L is my last term, R is my common ratio, minus A upon R minus 1. Similarly, if my absolute value of R is less than 1, I can write this as A minus LR upon 1 minus R. let's solve this question on sum of GP series. The first term of GP is 27 and its 8th term is 1 by 81. Find sum of 10 terms. So, is A equal to 27 given in the question, and T8, which is A r raised to 7 equal to 1 by 81 given in the question. Now if I put value of A here, 27 times r raised to 7 equal to 1 by 81. If I send 27 here, r raised to 7 is 1 by 27 into 81. If I write this in powers of 3, I am getting r raised to 7 as, this is 3 raised to 3 and this is 3 raised to 4. Therefore, r raised to 7 is 1 by 3 raised to 7. If I take the 7th root on both the sides, I will get r as 3. Now I have my first term, I have my common ratio. Can I find S10 by this formula? And my absolute value of r here will be greater than 1. So I will apply A r raised to 10 minus 1 upon r minus 1. Please solve this question further by putting value of A as 27, putting value of r as 3. Geometric mean between A and B. Suppose I have two numbers, A and B. Now the geometric mean works like that, if A geometric mean and B form a series, then they will be in GP. Therefore, can I say this is my T1, this is my T2, this is my T3? Will the common ratio, which is T2 by T1, which is geometric mean by A, will be equal to T3 by T2, which is B upon geometric mean? Now if I adjust this, I am getting geometric mean ka square is A into B. So therefore my geometric mean ka value will be square root of AB, and for square root to be positive, A and B terms have to be positive. So this geometric mean will be plus of square root AB. So if they give me any two numbers, suppose 3 and 7, and they are like insert a geometric mean between these two numbers, I will directly write geometric mean will be square root of 3 into 7, which is root 21.
Solving problem the border lets you notebook app together, the moment really down. I'm solving problems one beat at a time. ICSE math is a puzzle, and the solution is mine. And the solution is mine. And the solution is mine.